In this video, I'll be finishing up the remaining problems in this 1988 BC Calc multiple choice exam. Okay, let's dive right in. We left off on 38. What are the values of x for which this series converges? Alright, so I did not work this out beforehand, but immediately when it talks about convergence, what values of x, you should immediately think radius and interval of convergence, okay, which test do we use to find that? The ratio test, okay? Now, we could do the ratio test and find the radius of convergence and then find the interval of convergence, but since the choices are all -1 to 1, and whether they include them or not, or all real x, let's just check to see the endpoints first, okay? Let's check the endpoints first, because if one of them already don't exist, then this one can't exist, okay? I mean, one of them makes it diverge, then this one cannot be true. Okay, so hopefully that made sense. Let's check the endpoints. When x is -1, what's the series? It is -1 to the n over n. This is convergent because this is the alternating harmonic series. How about when x is 1? This would be 1 to the n over n. This is divergent because this is the harmonic series, okay? So it does not include 1, so it cannot be all real x. Okay, so this does not include, this includes, so it's either C or D. It includes -1, so it should be C. Okay, let's move on. Let me double check real quick actually. 38C, yes, okay. If dy dx is y secant squared x and y is 5 when x is 0, then y is equal to what? This is just separation of variables to solve the differential equation. So we move all the terms with y on one side and move all the terms with x on the other. So that's dy over y is secant squared dx. And then we integrate both sides. This side is log y. This side is just tangent x plus c. So we exponentiate both sides. Y is c e to tangent x. Remember, it's e to tangent x plus c, but we can separate it as e to tangent x times e to c. E to c is just some constant c. Okay? They give us y is 0 is 5. Okay? So that's equal to c e to the 0. We plug in x is 0. Okay? So c is equal to 5, meaning y is 5 e to tangent x. Okay, 5 more problems. F and g are differentiable everywhere. G is the inverse function of f. G of -2 is 5. F prime of 5 is -½ G prime of -2 is. This one, you just have to remember the derivative of inverse. I don't remember the formula, so I just quickly derive it every time. F inverse of x is y. Suppose that's the case, okay? We can rewrite it as x is f of y. Differentiate both sides. 1 is f prime of y, dy dx. So dy dx is 1 over f prime of y. Y is f inverse, so it's 1 over f prime of f inverse of x. So g is f inverse. Okay, so g is f in this case. So don't get confused by the g and the f and all that. So here basically, since g is the inverse of f, then we want to use this formula. So g is what's inside. G prime of -2 means we want g of -2 in here. And they give us g of -2 is 5. So it's 1 over f prime of 5, which is 1 over -½ which is -2. Okay? So the key here was remembering how to derive the inverse, derivative of inverse, because I never remember this formula. Okay? This one, limit as n goes to infinity of this guy. This, I did a similar problem in the last year, in the 1975, if that was the correct year. In that exam, this is Riemann sum. Okay, so we have to remember that the definite integral, remember, is limit as n goes to infinity, summation as I goes from 1 to n f of x sub I delta x, where x sub I is a plus delta x times I. Delta x is the width of the rectangle, b minus a over n. X sub I is the sample point starting from the right end point. Okay? So, just by how this is, looks like delta x is 1 over n. Okay? And the sample points are square root 1 over n, square root 2 over n, so on and so forth. So, this is f of the sample points. So, the function f looks like it's square root x. So we eliminate everything but b. Okay? And actually, you can even go and find the limits. We said that delta x is 1 over n. The first point is a plus 1 over n times 1. So a would have to be 0. And then this one, we're using right endpoints, right? So it ends at n over n, which is 1. So that's that. Okay? This one, if integral from 1 to 4, f of x dx is x, what's the value of integral from 1 to 4, f of 5 minus x dx? Okay? We can make substitution. U is 5 minus x. du would be negative dx. So our integral becomes, when x is 1, u is 4. When x is 4, u is 1. F of u negative du. Okay? We can flip our limits and add a negative sign. There's already a negative here, so we can make it positive. This is the same thing as this, just the variable name is different, right? So that's the answer. Okay, 3 more problems. Let's finish this. Bacteria in a certain culture increases at a rate proportional to the number present. So this should already signal exponential growth decay. If you don't remember, that's okay. If you remember, something is directly proportional to something, that's like y is equal to kx or something like that, right? So that, if you don't remember that this should signal exponential growth decay, you can remember that and derive it too, which I'll show in a bit. If the number of bacteria doubles in 3 hours, in how many hours will the number of bacteria triple? Okay, so once again, as I said, bacteria, the number increases at a rate proportional to the number present. So the change in bacteria with respect to time, that's the growth, right, is proportional to the number present, k times b. That's b is the number of bacteria. Okay, the change in bacteria with respect to time is sum k times the number of bacteria. We can solve this differential equation by separation of variables, db over b, move all the b's to one side, all the t's to the other, k is some constant. We integrate, this is ln of b is kt plus c, this is power rule. Then we exponentiate both sides. This is the same rule that we applied earlier. We can pull the constant here, c e to the kt. This is the exponential growth formula, if you remember, or even compound interest, okay? C is the initial value, okay? So that's B0. I notate it as B0 instead, okay? So when they say number of bacteria doubles in 3 hours, okay, so there's 2B0 when t is 3. So we can solve for k. 2B0, the final value, doubled after 3 hours, right? So we solve for k. So we divide both sides by b0. That's 2 is e to 3k. ln 2 is k times 3, or k is ln 2 over 3. So b of t is this guy now, okay? We're interested in what time it would be when the bacteria triples. Number of bacteria triples. So 3b0 is b0 e to ln 2 over 3 times t. So we just solve for t. So I won't go through the math, but afterward you should get t is 3 ln 3 divided by ln 2. Okay, so that is A. Okay, you can look at the math by pausing the video yourself. Okay, 2 more. Which of the following series converge? Okay, this one we can use the alternating series test because we know that 1 over 2n plus 1 is a decreasing sequence. Okay? And we know that limit as n goes to infinity, 1 over 2n plus 1 is equal to 0. So by the alternating series test, it converges, okay? This guy, well, I already can tell that limit as we can use the test for divergence. N goes to infinity, 1 over n, 3 over 2 to the n power does not equal to 0. So it diverges by test for divergence, okay? Y does not equal to 0. Well, this, when 3 over 2 is some number bigger than 1, so as you keep growing the power, it's going to blow it up, okay? And by the way, you can just do L'Hopital's rule too, because technically it's infinity over infinity, okay? But clearly an exponent is faster than just a linear thing, so that's why it would go to infinity, okay? Here we can use the integral test, but there's two conditions, remember? This is multiple choice, so you don't need to show it, but we have, for the integral test, it needs to be positive. We know it's positive because when n is 2, the log is positive, and 2 and forward, and the log is positive. So this is positive. Is it decreasing? Well, as n gets bigger and bigger, ln and both n and ln get bigger, but it's in the bottom of the fraction, so the total value gets smaller and smaller. So it's decreasing. We can do the integral test, okay? So integral of 1 over x ln x dx, we could let u be ln x, du would be 1 over x dx. So our integral we can write as 1 over u du. Okay? Oh, I forgot, from 2 to infinity. Sorry for forgetting the limits, okay? So this is just ln of, oh, I have to change the limits of integration, sorry. When x is 2, u is ln 2. When x is going to infinity, u is also going to infinity, so that top limit is right, okay? So it'll be log of u, we evaluate from log 2 to infinity. We get ln of infinity minus ln of ln 2. ln infinity is infinity, so this diverges by the integral test, okay? So the only one that's convergent is the first one. And finally, this one's also a longish problem. What's the area of the largest rectangle that can be inscribed into this ellipse? Okay, this is an optimization problem. Hopefully you recognize that. Okay, so what's going on is we have some ellipse here. You don't even really need to know how to draw this ellipse, but I drew it. If you remember, the standard form for ellipse looks something like this. So I drew it like that. We're trying to inscribe a rectangle in here. So let's define this portion as x, this length here, okay? And this length here as y. So the area of the square would be 2x times 2y, okay? Because there's x here, there's another length x there. There's a y here, there's another length y here. So 2x times 2y. That's the area of the square, okay? Which we can rewrite as 4xy. We want to optimize this, but we want to make it into one variable instead. So let's solve for y here or here, doesn't matter, we can do it from here. So let's solve for y, so subtract this 4x squared on both sides. 9y squared is 36 minus 4x squared. Divide by 9, that's here, okay? We can factor out 4 even from both terms, so I did that first. So y is, when we square root, the square root of 4 is 2. And then this guy we leave alone, but it's plus or minus, okay? It doesn't matter which one we take in this problem, because yeah, either the positive or the negative you can use, and you should get the same answer. You might get different coordinates, but when you figure out the area at the end, it'll be the same, okay? So anyway, so where was I? So we want to make this in terms of one variable, so we found what y is. I'm just going to take the positive one. So it'll be 2 square root of 1 minus x squared over 9. I combined the 4 and the 2 to 8 here, okay? Now we differentiate. A prime is, 8 is a constant, so I left that out. We need product rule, first d second. So first d second is this one. We need the chain rule, so you got to be careful. When we differentiate, the square root is 1 over 2 root of whatever's inside times derivative of the inside. So derivative inside, so derivative of this guy, 1 minus x squared over 9 is minus 2x over 9, okay? So that's first d second plus second d first derivative of x just 1, so that's easy. Okay, we simplify. I cleaned up over here. This 2 and this 2 would cancel. This x and x combines to an x squared. There's a negative there, so we can't leave that out. Divide by 9 is, I wrote this as a negative exponent instead, and then this as an exponent instead. Okay, I can factor out the smallest, so the smaller of the two, which is negative half. So that's what I did. Okay. When I factor it out, then this one's easy. We just left with minus x squared over 9. This we get half minus negative half, which is to the first power. So this, the inside to the first power is here, which we can rewrite as minus x squared over 9. Here's another minus x squared over 9. So minus 2x squared over 9. Okay, we set it equal to 0 to optimize. This guy is technically in the denominator, so the only thing that, so only this term could be 0. Okay. So 1 minus 2x squared over 9 is 0. We solve for x. We multiply 9 on both sides to make my life easier. 9 minus 2x squared is equal to 0. Solve for x. 2x squared is equal to 9. X squared is 9 over 2. X is plus or minus 3 over root 2. Okay. So we found x. That would be this point and this x and this x. The plus and the minus, right? Again, we just use the plus. So if x is 3 over root 2, the y is equal to what? Well, we can just use this one, okay? And then using the plus again, because once again, you'll just be finding the different coordinates, okay? Y is equal to 2 times square root 1 minus 1/9 times this guy squared, which is 9 over 2, okay? These 9s would cancel. So it's 1 minus half inside the square root, which is half, which we can write as 2 over root 2. So the area finally is, remember area is 4xy. So it's 4 times x, which is here, y, which is here, which is, we multiply all the tops together, that's 24. Multiply the bottoms together, that's 2. That's 12. Okay, so that's this guy. It's just tedious, and you have to be able to set it up correctly, knowing that we're trying to fit a rectangle inside. So we just define this length x, this length y. Then it was smooth sailing after that to an extent. It was just tedious when we got over here. You got to be careful. Okay. And that's it for this exam. Hopefully this video was helpful. If you were stuck on any of the problems, please give it a like if you found it to be helpful. And please subscribe to the channel to look out for more videos like this.